Lesson 6, Gravity and Friction. Let's start with a discussion on the difference between mass and weight. One of the biggest misconceptions in science is in the meaning of mass and the meaning of weight. We often use these terms interchangeably in everyday life, but they are very different. Newton's second law equation, the net force equals mass times acceleration, can be applied to objects that are free falling near the Earth's surface. During free fall, the net force is equal to the force of gravity, and the acceleration due to gravity is 9.8 meters per second squared down. So we can rewrite Newton's second law in the situation of free fall and gravity using the equation mass times g, where g is the acceleration due to gravity and has a value of 9.8 meters per second squared down. The force of gravity on an object is called weight. Therefore, we can calculate the weight of an object using the following equation for gravity. This is our equation for gravity. Where m is the mass in kilograms and g is the acceleration due to gravity. And it's equal to 9.8 newtons per kilogram down. Now note, if you find the force of gravity that the Earth exerts on an object, it's equivalent to the weight of an object. So weight is measured in newtons. Let's look at these two definitions. Weight, the force of gravity on an object, measured in newtons. Whereas mass is the amount of matter in an object measured in kilograms. Let's try an example. The maximum train load pulled through the train tunnel is 2.434 times 10 to the power of 6 kilograms. Determine the weight of this load. So we know that weight is equal to the force of gravity, which is therefore equal to the mass of the train load times the acceleration due to gravity. We can sub in these values. We know the mass of the train load is 2.434 times 10 to the power of 6 kilograms. And G is 9.8 newtons per kilogram. This is the acceleration due to gravity. This is a constant value. This is something you will come to memorize. It is the value of the acceleration due to gravity, and we use it whenever we are calculating the force of gravity on Earth. If we were using a different planet or a different celestial object such as the moon, then we would use a different acceleration due to gravity. For example, this value would be smaller on the moon. On the moon, the acceleration due to gravity is 1.6 newtons per kilogram, about 1/10 the gravity of that on Earth. So let's punch this into our calculator, and carefully, because we have scientific notation, so make sure you punch this in correctly. 2.43 times 10 to the power of 6 kilograms times 9.8 ends up being 2.4 times 10 to the power of 7 newtons. Therefore, the weight of the load is 2.4 times 10 to the power of 7 newtons. Okay, let's move on to our next section, which is called friction. We described earlier two types of friction. kinetic friction, and that's the friction that is present in moving objects, and static friction, and that is the friction that is present when objects are at rest on a surface. So the force of kinetic friction, F with the subscript F, is proportional to the normal force. And we described the normal force in our previous section as the force with which a surface presses up on an object. So we end up with an equation for kinetic friction that looks like this. Force of friction is equal to, this letter here is the Greek letter mu, and it stands for the coefficient of friction. And the normal force is the force with which a surface presses up on an object. And whenever an object's resting on a level surface, it's equal to the force of gravity and can be calculated using this equation, mg. Okay. Let's talk a little bit about the symbol mu, which is used to represent the coefficient of friction. The coefficient of friction is a number that indicates the ratio of the magnitude of the force of friction between two surfaces to the magnitude of the normal force, Fn. It's a constant value, and it only depends on the nature of the two surfaces. So, two surfaces rubbing past each other will have a high coefficient of friction if there is a lot of friction between them. For example, imagine a rubber puck on a rough road. If the two surfaces have little friction, examine or imagine a rubber puck on ice, which is why they choose rubber to make the puck in the game of ice hockey, then the coefficient of friction will be really low. The only way to change the coefficient of friction is if you change the two materials that are in contact. As I mentioned, we have two types of friction: kinetic friction for moving objects and static friction for objects that are at rest or objects that are stationary. These equations are identical. The only difference is the coefficient for kinetic friction will be specific for objects that are moving, and the coefficient of static friction will be consistent or specific to objects that are not moving. In order to better understand this, it's best that we try some examples. Note, the reason why the coefficients are different for moving objects and objects that are at rest is because it's harder to get an object moving than it is to keep an object moving. Here we have a list of coefficients of friction. You can see this is a chart that shows these constant values. These values don't change, and you'll often have to look these values up in a textbook or online if you're trying to determine the force of friction between two surfaces. So we have things like rubber on dry asphalt, and this is an important coefficient of friction for moving objects or objects at rest because rubber is used on tires, and tires drive on asphalt roads, so we want to know how much friction is present. Notice that the numbers change when the asphalt is wet. The values for the coefficient get smaller, which means friction gets smaller, which means that these surfaces are more slippery. Okay, let's try an example. 4 athletes on a bobsled have a combined mass of 695 kilograms. They need a force of 410 newtons forward to get the sled to start to move. In order to get the sled to start to move, this means that the sled is initially at rest, which means that we're looking at static friction. And we want to calculate the coefficient of static friction for the sled on the snow track. So, we are given the mass of the athletes on the bobsled, and that's 695 kilograms. And they need a force of 410 newtons just to get them to move. So the force applied on them is 410 newtons forward. So I'm going to do my best to draw an example of a bobsled. And there are 4 people on it. One guy in the front is driving. So in order to get this to move forward, you have to apply a force of 410 newtons. What that means is in order to get it to move, you have to overcome static friction. So if it takes 410 newtons just to get it to move, that means that static friction must be present and must have a magnitude or a size of 410 newtons backwards. Okay. Our job is to find the coefficient of static friction, which is equal to the force of static friction divided by the normal force. Now, remember, the normal force is equal to the force of gravity, and the force of gravity is equal to mg. So we can put in our values. The force of static friction, we said, is 410 newtons backwards. The mass is 695 kilograms, and G is 9.8 newtons per kilogram. If we punch this into our calculator, 410 times, 410 divided by 695 times 9.8 equals 0.060. Notice you don't put any units, we just have a decimal number, and we can say the coefficient of friction for the sled on the snow track is 0.60. I want you to try these homework practice questions. As well, at the end, you will find an LMS quiz on this section. Good luck.